Now, let me find the slides for today. There. Good. I think we're here. Sorry about the late start. I've been having a variety of technical issues and dealing back and forth with Top Hat on dealing with it. They're very good in terms of support. I don't know if you've had to use them for any technical support, but I've got someone that she gets back to me quite quickly. She's in Toronto, and so she's just getting into the office and trying to answer a whole bunch of questions I've sent. So hopefully things are okay now, and I can get underway. Let me see if I can shrink that back a little bit. Oop, too far probably for my slides. Anyway, I'm in need of more pictures. I've got a number of you who have sent me several each, and so I'll go back and use other ones that group has sent me. But I'd appreciate it if more different people sent me some pictures to include as well. Dominic sent me this one that I'm trying to gauge is that a sunrise or a sunset. Could be either one. I'm not sure. I presume no, I think that's a sunset. I think that would be to the west. So it's Dominic sent me several pictures, I think when he was camping. I know he gave me a whole story behind them, and I misplaced that. That one of them is a place I'm totally unfamiliar with. It's on the Tony River, which I'd never heard of and had to look up. It's on the Northumberland Strait, if you know Nova Scotia. If you went up to Pictou and then headed sort of northwest, I guess, from there towards River John and Hattamagush and up that way. It's along the shore that way. And lovely, peaceful space there. And then I got a picture for you that with this lovely weekend that we've had, the snow, it's nice and crisp and we're getting sunshine. Except yesterday, I didn't get, at least when I had the picture taken, it wasn't sunny. It was a little bit overcast. It got sunny not long afterwards. But unfortunately, when Bernie was there to visit, it wasn't sunny. So Bernie dropped by to compare mittens. I got new mittens for Christmas. And I would remark to him that it sort of looked like his. So I can see his are a little more colorful than mine are. But this was fun. Never did this type of thing before. I don't know how to do these things. Had to look online because everyone seems to be getting their picture taken with Bernie. He's a very busy man traveling all around the world. If you don't know what I'm talking about, well, yeah, you've missed something. And hey, I don't follow social media. If you missed it, then you're missing an awful lot, I guess. Anyway, some updates for you. So the test that you had on Friday, the results were amazing. So many of those scores it's out of 16 points, and seeing scores of 16, 15, 14, 13, they were all up the very top end. Um, Average was approximately 90%, whereas last term, test one, the average was around 71%. Now we had some, yep, we'll get to those in a minute. Let me run through these and, well, just give you an update on testing. But start typing the question you've got, Abby. The In the fall, it was multiple choice, and there were a couple of short answer, but the average was closer to 70%, and on subsequent tests was lower than that. So it's a different crew in the fall than in the winter. Very, very different demographic mix, and but also they were taking their first, online set of courses. Huge stress level in the fall. Your survey seems to suggest it's still there, I think. But I know it was, we had a lot of issues with students in the fall. And hopefully it won't be the same this term, but many of them had a fear that they might get through the fall, but uh, the isolation was probably going to kill them during the winter. We shall see. If that's an issue with you, please reach out, contact me or contact someone, see where we can go from there. Quiz 3, the scores are still very, very high, a little bit lower than before, but we were starting out at 97%, I think, at the beginning, and now it's still around 90%. So grades are really good, but be warned, chapter 4 gets into pivot tables, and uh, and 4 and several of the subsequent chapters students found very challenging, both in the material and in the questions I posed. So the grades will slip a little bit, hopefully not too much on the quizzes. Still last term, average grades on quizzes were generally above 80%. So I'm still looking at high scores there. I'm a little more concerned what might happen on test 2. It didn't go well last term. But, so far, you guys are doing extremely well. So, okay, there was a question about the assignment. That what I generally want you to do on the assignment, open that Word document and put your answers right into the Word document. Since you're not having to print it, whether your submission is 10 pages long or 4 pages long doesn't matter. Okay? But I'd put them right into the assignment. It makes it easier for you if you had to review that assignment subsequently. But just type it right in there as a Word document. When you're finished, though, save it as a PDF and submit a PDF document with things in it. That sometimes with submissions of Word documents, had in the past, we ran into some problems a year ago with some of that. But assignment 1, we're already hitting some challenges on that. There were a number of emails on the weekend from my students, and talking to the other instructors, they're getting the same ones. And I'll show you what the problem is when we get into Excel today. But they've all been having to do with VLOOKUP, and the VLOOKUP function doesn't seem to work. And it has to do with formatting a cell in the table. And normally it should be formatted as just general, but Excel seems to be almost randomly formatting them as text, and that creates difficulty. So I'll show you an example of that later and how to fix that. And if you're continuing to have trouble, just email me about it. Now, at the end of last term, I surveyed students yet again. I do lots of these things to get input, and I asked them 6 or 7 questions about the course, and in particular about things that were well done, poorly done, what should I do differently, improve the course. So they were all open-ended questions. And they gave me lots of good advice and feedback. With respect to assignments, they gave me 2 pieces. One was they wanted to see sample problems. And traditionally in teaching a quant course, like for many of you that took Quant 1 in the fall, back when I was teaching that, I'd always post tons of old questions. And so the way many people do when confronted with a new task, they look for examples, and they do the new task by imitating the examples. It may be that for me doing a new task for the first time, I might search on YouTube for videos on how to do something or other, and it would walk me through an example. So I'd walk through the task I'm doing the same way. And I've learned a variety of things that way. And that was the way generally students seem to be. They learn things. They do it by imitation for the first few times, and then once they get mastery of it, they don't need to look back and do it. But the first time through, seeing someone walk through an example is really helpful. With math problems, if it's laid out and it shows you the different steps, yeah, that's good. What do you do with Excel? So, because I went and I posted, there's a folder on Top Hat that is Assignment 1 Fall 2020, and it has Assignment 1 from the fall of last term and the marking key for it. If it was a math problem, that's usually enough to be able to figure out how to do it. But with Excel, it probably isn't. That it just shows you the answer, it shows you screenshots. And so that related to the other thing they wanted, which I tried to do in the text for this term for the first few chapters, is to have some how-to videos, how to do certain things. And I will be building more. I got them done for the first few chapters, but I need to add more as we go through the term. But what I did was I went back and I gave an explanation of how to do assignment 1 from the fall in a video. So there are 2 videos, they're 20, 25 minutes each. First one goes over how I did questions 1 to 4, and those were the first preparing your spreadsheet videos. And then the next one were um, the they're private. Okay, they're not coming up. Oh, they should have a link. Okay, I've got to go into YouTube and change the settings. Um, YouTube said that if I put it up as private, as long as you've got the link, it should go through to you. It's just that people generally searching on YouTube wouldn't run across it. It doesn't show up on my YouTube channel, they said. News to me. This is all new. Yeah, it's called unlisted or something. Okay, I will change the setting on that, and I'll do that right after class. And if necessary, we'll make them all public. Um, that so the videos should walk you through how I did the questions. So, and your assignment is has you do the same type of tasks with a different data set, different survey, and their surveys are different, and some of the tasks I'm having you do things a little differently, but just for a bit of variation more than anything, so you don't just copy it. But the one from last term should give you a good enough idea, except for cases like this one to do with VLOOKUP. Never had the problem we've had occur to me before, so it's a new one. But we'll do that. And with the assignment after it's submitted, I'll also be posting, normally I post the answer key, so you could mark yours. But when you get it wrong, it's like, what should I have done? I'll be posting videos of how to do the assignment as well. And so I'll be posting those sorts of things for you so you can see how you could have done it yourself. And I would appreciate feedback on that. It's new to me, haven't done these types of things before, and what should be included or not included in a how-to video. That say my students last term taught me a variety of things, and I hope that you will teach me as well. I never stop learning. That learning is a lifetime endeavor, should be for all of us. So last class, we started looking at data and looking at patterns potentially in it. We're only looking at a single variable at the moment. Next class, we're going to look at relationships. But right now, looking at a single one. And we did, looked at what were the small numbers, what were the large ones, what were the middle ones. Are they all spread out, clustered together? It's hard looking at 752 numbers at once. So we did look at summarizing in a table, grouping numbers together, and looked at that as a table, which some people can process well, but many people are overwhelmed by those and work much better with graphs and pictures. I learned that lesson when I used to send out weekly reports to the deans in art, science, and business, and the vice president and the president. about enrollment patterns or things that were happening with students or trends that were occurring. And I gave them the data in a tabular fashion, and I figured they could read that. And I discovered there were certain um, individuals that looked at it and just um, they got overwhelmed. Too much information. Uh, so I started sending it out as a set of graphs, and then they could look at the tables if they wanted to. The response was completely different. Made sense to them when they saw pictures. But they like picture books, but they don't like to have to do a lot of reading, sort of thing. Um, these were very bright people, but they're not unusual. A lot of us are visual learners, so histograms were useful there. Yeah, I like picture books too, comic books. I think I may have told you it's how I years ago. I've now forgotten it all, but I learned German by reading comic books in German. Um, so you can. We looked at simple summary measures through the total row, and I'm going to be doing that a little bit today, but I'm going to be showing other ways of getting that. Still clumsy, but they're common methods people use. And then next two classes are going to show you a nice, powerful tool that makes it's really slick. It does a lot of these things in a very professional fashion. But in my experience, very few people know how to do it properly. So we'll get into how do you do that. And it's generally not taught in any of our classes here, which surprised me. So today I'm going to look at simple, basic summary measures. These are what's called descriptive statistics, numbers that describe things, that like minimum and maximum or average, middles measures, that type of thing. And I'm not going to have you calculate them by hand. I think that's a waste of your time. You're going to have Excel do it for you generally, some type of software. Occasionally you have to do it by hand with a calculator, but it's only of a small number of values. If you've got a lot of data, you're going to make data entry errors and make mistakes. So you best do it in things like a spreadsheet. Uh, but I want you to understand what they represent. And I don't care if you know how to calculate it, but I do care if you know what it is. And the traditional way we teach this material, the focus is on how to do it and not on the interpretation, which is backwards. So if I'd given you back a test like we had last term, where the average was 70% or so, so there was a broad mix of grades on the test. Generally, students will, the first thing they'll ask me, they get their test back and someone got an 82 and thought, sort of good, I guess. But I don't know. Like if you got 82 on quiz one, you might, all right, great, A minus. But if you were then told the class average was 90, you'd say, oh, okay, good, but it's not as good as everybody else. You To evaluate 82, you needed to know what the average was. You'd be happy if the average was 71. You might be disappointed if the average was 90. But your grade is an 82, shouldn't you be? We evaluate things by looking at them relative to some sort of standard. You can't evaluate a number in isolation. You need some reference. And the most common reference people use is the middle. Am I above the middle or below the middle, or am I just in the middle? Where am I? And so we need a measure of middle. Now, I've also used the word average, and most of us talk of average. Am I above average or below average? There's a little bit of jargon today. In the world of statistics, they're fussy about their language and their jargon, and they don't like using the word average. They like to use the word mean, that's our traditional average, or median, and then there's some other things. other measures they use of middle. But the mean and the median are far and away the most common measures of the middle. So let's go through as to what they are and how they're different, how they're similar. So this is what we think of as average. I take all the grades, add them all up, divide by the number of grades. That gives me the average. In statistics, we'll call that the mean. And if it's from a sample, we'd call it the sample mean. So it's just of that group, not of everybody. So our class would be a sample of all the students that are taking the course this term. So there are 8 sections altogether here. In terms of symbols, it's not important for this course, but you'll see it in your stats course. So just so you're aware. And statisticians, like any mathematician, like symbols. It's their secret recipe. That they have their own secret handshakes and those types of things. They have symbols. So they would normally use X to represent a variable that we're studying. And they'll put a line over the top. They call it X bar, B-A-R, bar. So there's a bar on the top, usually to represent a sample mean. And in words, it's the sum of all the values divided by the number of values. In symbols, they use this squiggly thing. It looks like an E. It's a Greek letter S, and it means the sum of. So the sum of all the observations. So that's what the squiggly guy says, the sum of, and X is the observations. And they'll generally use a small n to represent the number of values that we've got. Okay? Simple formula. But if you've got 752 values, it's a lot of work. In this formula, 2 things are important when looking at it. First, all the values are equally important. The student that said they were going to earn 50,000 is just as important as the one that said they thought they would earn only $500, and that's just as important as the student said they were going to earn 650,000. You might think they shouldn't all be as important, but standard practice is to include everybody and treat them equally. If you want to treat them unequally, which in practice is done in certain cases for specific reasons, we would call it a weighted mean, a weighted average. Some have more weight than others. We're not going to do that, but be aware that's out there. The other is that all the values are included. And last class, we noted some of them were silly values. People saying they were going to earn 0. Then you didn't have a job. Why should we be including you? You're still in school or something. You're going to finish and go on to do a law degree. So 2 years after graduation, you're still in law school. Fine. But we're not going to put your 0 into this. We're looking at those that are 2 years after graduation are going to be in the workforce. That's the implication here. Similarly, the one that said 650, I'm sorry, I don't want to include you. I'd like to exclude you. So sometimes we talk of a trimmed mean. We trim off values. We're doing that. We did it last class. We're going to do it maybe again today. Just be aware of that. That's not the traditional interpretation of the mean, though. So if what we did in class was we went to the total row in Excel, we pulled up average. So Excel calls it average, not mean, and we got that $52,914. Okay. That the other term for the middle is the median. And so if you were all in a classroom and I could see you, and I wanted to find what is the typical height of students in the class. Okay. And I didn't want to get out and measure everybody. I could have you all assemble at the front of the room and we'd shuffle you around so that the shortest person is over at one end of the front, the tallest at the other, and you all progressively go up across that way. So I've sorted you from smallest to largest. And then I just count my way to the middle, and I'd grab that person in the center and maybe measure that person. That person's in the middle. Their height is in the middle. That's what the median is. It's the value for which 50% are smaller and 50% are larger, half and half. And so it is the middle in that sense when we've sorted our data. So that as well, we can get out of the total row, but we'd have to do it differently than we did in class. So let me go over here. And this was the data we were using. And so here are my salaries. So I could do the sort like I did before. And I could go and scroll through it. There's 752, so I could go to number 376 or thereabouts, down here somewhere. Oops, I passed it. Excuse me. Not paying attention. 376. It's around $50,000 then. That's the middle. If you were using the total row, just to show you, I was using it for something else from the other class. I could go to, oops, excuse me, grab the wrong one. It's not in my list here, but if I go to more functions, and there are different groups of them, I could go to all, or this is a statistical function. I could go to that list, and then they're all sorted here, and I scroll down, and here it is, median. Click OK. And I don't know what that's telling me. There it is. It's 50,000. Okay. So the median value is 50,000. Half the students reported earning their salary below 50, half above 50, or exactly 50. As to how to find it, as I said, you could sort the data. You could in this one there's 752 that have real values. The last one is in row 753. Halfway through is 376. So I could count down 376 values, which would be the 377th row. I've got labels, headers up at the top. Or I could have counted from the other direction, counted from the bottom and gone up. I still get 50,000 in both cases. Counting from different ends, you're actually different values, and so they could be different numbers. If they're different, just average the two. Which one do you use? The median is attractive because it's not affected by outliers. It only is affected by the numbers that are right in the middle. If I look again at this, that when looking at row 3, whoops, so they were all 50s. They were all together in this bunch. But I don't care what the numbers are below it or above it. I just care about this one. So if the smallest value was 40,000, I don't care. If the largest value was 7 million, I don't care. Because I don't care about the ends. I just care about the values that are in the middle. So if we want a measure of the middle, it's pretty good. It's a measure of the middle. On the mean, on the other hand, includes all the values. So it's affected by if the last value was 650,000, or if it was 150,000, or if it was 650 million. That's all of those cases, it's going to affect what the mean is. And that may be disturbing to you. But in practice, when people think of average and middle, they think of mean. They don't think of the median. The median, you have to explain it to them. And you're going to distract from your presentation what it is you're trying to explain to people. And you may lose your audience or confuse them, whatever. So very, very, very few people use the median unless they really have to. And there are certain compelling cases where it is important. Um, if I was shopping for a new house and I wanted to know, well, what are house prices like in Halifax? And the mean house price might be, I don't know, $440,000. Big number. That's expensive. But that's the average. That includes those $1 million homes, those $2 million homes, the $10 million homes on the Northwest Arm. I'm not buying one of them. I'm buying a middle house, and that's not a middle house. And on the bottom end, it's truncated. You aren't going to get homes in Halifax selling for less than $200,000. You'd be hard pressed to find anything down at that end. So we tend to have this big bulge at the beginning and a long tail. So if I was looking at house prices, I might ask, what's the median house price where 50% are less expensive and 50% are more expensive? And you might find that the median house price is $350,000. Half the homes are probably between $200,000 and $350,000, and half the homes are between $350,000 and $1 million. The median might be a better indicator of the middle. Okay? But it depends upon the context. The other thing, if you got your test back and you got an 82, and I told you the average was 90, and you're really disappointed, you should have been really happy. At first you were with the 82, but then when hearing the average was 90, you get sad about that. And you think, well, um, diddle, are there many students like me that only got in the low 80s? Are there some that are down in the 50s and 60s or 30s and 40s? So help me feel better about my grade. So you might like to know, well, what was a low grade on the test and what was a high grade on the test? I know what a high grade would be. It would be 100. So I've got a whole bunch of people that are lumped together between 90 and 100. But the rest that are below 90, are they widely spread out? What's low? What's very low? That um, we need other things. It's not just the center, but we need other reference points as to big and small. Can you tell me what those are? Those are harder to define, and we don't have any accepted definitions of what is big and what's small, what's high and what's low. Everybody defines it differently, but let's go and look at it and ways that we can try to define it. Because if we're going to talk about high income earners, we're going to have to define what do we mean by high income, and not necessarily in terms of a dollar amount, but in terms of um, are lots of people earning that? Very few people earning it. Uh, that don't hear it as much this year, but a few years ago, there was a lot of debate about the top 1%. The one percenters, the very end, top end, that were earning huge salaries, accounted for 20, 30% of salaries paid in total, of all the money paid out to people. 20 to 30% were going to 1% of the people. So a small group were getting a large amount of money. And then the rest of the money was being spread out to everybody else. So that was the super earners. But sometimes you might say, well, are you in the top 2%? So if we had to define what would be high income, how would we measure that? Top 1%, top 10%. That gets into a thing called percentiles. So the top 1% of 752 is 7.5. So let's find who is the 8th highest salary. Let me find them. So I've got it sorted, and I've got it largest to smallest. Oh, good. That's great. So count it down. 1, 2, 3, 4, 5, 6, 7, 8. 175,000. 1% of students expected to earn above 175,000. Okay, right? How about if I define it as the top 10%? Okay, then it's 75. Let's go down to the 75th largest. Or if you want to count from the other end, if 10% are above, 90% are below. And you can count whichever way you want to do it. And you're going to find that number is 80,000. How do I explain that to someone? Well, we've got names for it. We would call 80,000 the 90th percentile, in that 90% earn less. So percentiles are defined in what percentage are below that. And we might define high and low in terms of percentiles. Low, maybe the 10th percentile, high, the 90th percentile. That often low income is defined as being in the bottom 20th percentile. 20% earn less, and that would be low income. That they're nice in that they're not affected by really extreme numbers. Okay, they are towards the end potentially, but not the very, very, very end. So generally outliers aren't an issue. That the 50th percentile is the median. 50% are below, 50% are above. If you want to keep it really simple, we'll use this definition later in the course when we're looking actually at pictures of data. Look at quartiles. So I take my 752, split it in half. Bottom half is below 50, top half is above 50,000. That was where we found it in our data set. 25th percentile, I'll take the first 50% and I'll cut that in half. So I'm cutting things into quarters. And so I have 25% below the first quartile. Then the next quartile goes up to the median. And then I go up 25% to the third quartile. And then the top are those that are above the third quartile. So I talk of quartile, but there are actually only three values. The value that splits it in the middle, and the value that splits the first half, the value that splits the second half. Quartiles are nice just because of their simplicity, and it's easy to find. It's like cutting a pizza. And we often use them not for the specific numbers, but to form groups. I've used it before. I know economists do it in similar fashion. When looking at student success, I would take a community of students, split them into quartiles, and then I would take the first quartile, those that had the lowest performance, and I would create a profile of what do they look like? What's their gender? Where are they from? Where did they go to school? What courses are they taking? What program are they taking? And try to see, are there certain common features? And then I'd look at the top 25%, the most successful students in terms of grades, and I'd do profile of them, and I'd compare the two profiles. So what are the distinguishing characteristics between the students with high levels of success and those with low levels of success? And from that, maybe find ways of assisting that lower group to move up into the other group. What types of supports, advantages do they need? Maybe those in the bottom group are more likely to work part-time jobs to pay for school, and those in the top group don't work at all because their parents have lots of money. That, okay, this group needs financial assistance. They could work fewer hours, and maybe that would assist them getting into that group. Don't know, but I'm looking for insights. That so it's least and most successful are ways of using quartiles. In each of these instances, we're sort of looking at the issue of diversity. How diverse is this mix of students? On your test one, you aren't very diverse. Almost everybody did really, really, really well. But if the average had been closer to 70%, then the grades would probably be more diverse. Maybe not. If the average was 70, do we have students going from 20 or 30% up to 95, 98%? Or do we have almost everybody getting between a 60 and an 80? Nobody did extremely well. Nobody did really poorly. They're just lumped together. Can I measure that diversity? It's harder. Talking about diversity is easy. Measuring it is not, because you end up with a number, and how do you interpret the number? So, different approaches. I could find the range, difference between the biggest and the smallest. Don't do it, because the maximum is an outlier, the minimum is probably an outlier. So all I'm talking about is how different are these outliers at the two ends. Bad news. I could go and say, what's the gap between the 90th percentile and the 10th percentile? Yeah. I could look at the gap between the third quartile and the first quartile, and we'll use that measure actually later. It's a nice simple one, and see how far apart those are. But generally, people don't use those measures. They're not widely accepted, partially because you have to explain them. But actually, the one that they do use is even harder to explain than any of these. And I'm going to walk you through it. They like to measure variation or diversity by gaps. So if the middle is 53,000 and you said you thought you'd earn 20,000, then you're $33,000 below the middle. If you said you were going to earn 65, you're $12,000 above the middle. So how far away are you from the middle? And now if I did that with all of the values, some are very close, some are far away, and I looked at, on average, how far are they from the middle, then I'm looking at taking absolute values, get rid of that minus sign that's up here with the 32, get rid of that, and then finding the mean value, the average. And it's called the mean absolute deviation. And it's relatively simple, easy to explain as things go, at least when talking of these deviations. It used to be measured or used many years ago. It isn't today. Mathematicians do not like it. Statisticians don't like it. In practice, though, it used to be widely used in forecasting. We would use it to describe how far off is your forecast. Well, sometimes it's too high by 33,000, sometimes too low by 12,000. On average, it's off by $20,000. And people could understand, oh, on average, your forecast is off by 20,000. That made sense. And it's still, you may see this term in some articles about forecasting, but otherwise, it's very rare to see it used. As I said, it dates back a long time ago. Think back to before we had computers readily available and you were doing things by hand. This could be done by hand. But mathematicians don't like absolute values. If you want to get rid of the minus sign, you want to balance off the minus 32 with a plus something, you can do that by squaring numbers. So if I had a minus 4, square it, I get plus 16. If I had a plus 5, square it, I get plus 25. Every time you square, your number ends up, your answer is a positive number. So let's look at those deviations, square them, and average them out. Okay, so here's my formula. You don't have to remember this. I'll never make you do this by hand. That would be cruel. Though you might in a stats course. They're nasty people. So you take the observation, say 20,000, subtract the 53,000. So I get the minus 33,000. I'll square that. Do that for each value. The squiggly things means add all of those squares together. And I'm going to find a mean value. Now, before we divided just by the number of values you are adding up. Turns out now for a sample, we divide through by the sample size minus 1. It has to do with getting a biased result beyond the scope of what we're doing here. And it's a crazy formula from the outset, so who cares? This is given a name. It's called variance. You'll see it in statistics. They talk a lot about variance in different contexts. You sometimes see it in finance. They talk about the variability of stock returns. So if a stock that value bounces all over the place, it has a high variance. Whereas a stock whose value stays about the same every day, it has a very small variance. But finance people seem to talk about variance. Almost nobody else does. Accountants talk of variance, but they have a different meaning for it. What I find troubling with it in particular is the units. These were dollars, differences that are still dollars, that are squared, so they're now square dollars. And in this case, my variance ends up being 1 trillion or 1,940,893,817.64 square dollars. Awfully big number. That's separate from explaining what this is huge. How do I understand this? It's the issue of square dollars. What's a square dollar? Um, you put your bank card in that bank machine to withdraw some cash. Does it spit out square dollars? No, it doesn't. it, it'll spit out dollars. What do square dollars look like? I have the faintest idea. So we can fix that. We can always fix things. Take a square root. So I take the square root, I get $44,000. Great. The units are things I can understand. The number, okay, it's smaller. It's not in the billions. But what is it? How do I make sense out of that? Um, I don't know. It's a very strange number. And when you look at the formula, it's if you were to explain to your mother, your father, oh, I calculated the standard deviation. That's the name given to this. How did you get that, Malcolm? Well, I took each value, I subtracted off the mean value, and then I squared the number and I added them all up and I divided by the number of values minus 1, and then I took a square root. What is that? I have no idea. But it is the far and away the most widely used measure of variability. You're going to see it everywhere. Everyone uses standard deviation. What is it? How can I use this? Is it just a number? Yes, no. There is more to it. And I could get it with the numbers we've got here. I could go down to my total row, zip down to the bottom here, click there, and here it is, STD-DEV. There it is. That's my 44,000. But how do I interpret it? You can, and this works in a large number of most situations reasonably well, but not all. It doesn't actually work with our data very well, the way we have it at the moment. But if our data, if I summarized it with a histogram, if it looked sort of bell-shaped, I don't care if it's lumpy, but if it's reasonably symmetrical, some go off to the left, some to the right, then I may be able to use a thing called the empirical rule. The dangers in using this is when my data has a long tail off to one side, so my data is skewed. If I've got some really bizarre outliers, I have trouble. So if it's nice data in that it's not, it may have a little bit of a bend to it, maybe a bit of a tail on more on one side than the other. It's not perfectly symmetrical, but it's still not too bad. It's bounded, and I don't have extreme values. That's a bigger issue. No extreme values. Then this is what we can do. The rule in general says that if your data is bell-shaped, it's called a normal distribution is the technical term for it, then approximately 68% of the values, about 2/3 of the values, should be between one standard deviation below, one standard deviation above. This isn't going to work with our data. Okay? Our data has a mean of 53, right? A standard deviation of 44. So going one below is going to take me down to 9,000. Going one above is going to take me up to 97,000. I'm going to have more than 2/3 of my data in that range. I'm going to have most of it in that range. But if it wasn't, this would work. About 2/3 would be there. That if I take 2 steps out, go out 2 standard deviations, 2 times 44 is 88. So if I went $88,000 below and $88,000 above, I'm going to get silly numbers. But if those numbers had made sense, I'd have 95% of my data. And if I went out 3 steps, so that would be 120, 132,000 below, 132 above, chances are I'd have pretty much everybody. I might have one outlier or 2 outliers, but that's all. It doesn't work with our data, okay? And it's because we've got those outliers out there. But if I take the outliers out, so let me go back to my Excel data here. Let's filter this. I don't know, let's say take out things below 10,000 and above 120. Okay. Oops. Or no, I want to take it a little further. Oh, that doesn't look right. Something's wrong here. I must have made a typo. Probably had 12,000 or something. Let me do this again. But I can't put commas in here to help me. Again. There, 20,000. That's a lot smaller than 40. And if I look at the mean value, the average, it's 50, roughly. So if my middle is 50 and my standard deviation is 20, what do we get? That it looks like I've got maybe a typo here. But if I go out one standard deviation, I'm going from 50 minus 20, or 30,000, 50 plus 20, up to 70,000. About 68% of the values are between 30 and 70. If you go and look at the data, you'll find about 30% are in that, or 68% are in that range. And if I go out 2 standard deviations, I'm going to go from 10 up to 90. And most of my data are in that range. So taking out the outliers, this rule will start working properly. Still, why am I doing this? It's what we call a quick and dirty rule, something to remember how to interpret a data set quickly without doing a lot of work, stuff that you might be able to do approximately in your head if you round off the numbers. So if I wanted to define high and low, I might say, oh, that's 1 standard deviation below to 1 standard deviation above. Very high, very low, I'll go down 2 standard deviations and up 2 standard deviations. So those, out of knowing 2 values, the mean and the standard deviation, I can come up with a 5-number summary that says what's a very low salary, a low salary, a middle salary, a high salary, and a very high salary. I can create a picture of the salaries very quickly, just knowing the 2 numbers. And that's why it's really powerful. And it works in a huge number of instances. Not exactly, but we're just trying to get a picture of things. So a picture isn't perfect either. It's an approximation. Now we can also do these things within Excel. And I got to zip through this. I seem to be running slow. In Excel, if you go to the Data Analysis tab, there are descriptive statistics. That's what these are. and I'm going to go through and get them. So let me go back to Excel. Let me take my filter off here. Clear it. There we go. Okay. And I'm going to go up to the tab that says Data. I'm going to go to Data Analysis. And in this list of things, you probably can't see it, but it says Descriptive Statistics. Click on that. Now, this is left over from last class. Let me just take that out. So, my input range, it's in this column here, column L. I could go and highlight everything. I'm going to just type it. So it's L1. That's very top label here. And it goes down to L812. So let's just suppose I didn't know how many blanks I've got here. This won't care about the blanks that are there. The bottom of this table is the row 812. They're arranged in columns. I have labels in the first row. So if I don't click this, it's going to give me an error message because this is text and this is numbers. And I want summary statistics. Click OK. Okay, I've put it in a new sheet. Most of the time I put output in a new worksheet so it doesn't clutter my data sheet. So here are the numbers. I'm going to widen this so you can read what the labels are. And I'm going to widen this so that funny number here that was in scientific notation isn't that way. We've already looked at the mean. So here's of things that we typically will want to look at. The mean is 1. We looked at the median. Okay. We've looked at the minimum, is that last class actually, and the maximum. We looked at the range, which is the difference between the two. Okay. We saw earlier how many values, that's the count, that showed you, where is the variance? Chances are you're not going to use it as a number, okay? But we've seen what it is. Standard deviation is something you would use. Okay? I took the filter off, so it's all the data, but actually, as I mentioned last class, the data analysis tools don't recognize filters. So even if I had used the filter and filtered values out and then asked for data analysis, it ignores the filter. The only way I can filter is to apply a filter, copy that data, new sheet, and then analyze the new sheet. It's a frustrating thing. And then there are the things that we have, sum, that's just the total. I don't know what you'd use it for. And there's other ones here. The mode, I would not use. In my mind, I would, sorry, it doesn't have that as a thing. Can I do a strike through, get rid of it? Yeah. Mode is something I don't want you using. It's the value that occurs most frequently. And since students rounded off their answers, we'll find that the mode is 50,000. That was the most common value. But if this was actually tax return data, so I knew exact salaries, all of the numbers would be slightly different. And there might be one number that occurred 2 or 3 times by accident, but it's nothing special. It shouldn't get any special attention. If I summarize things with a histogram, goes up, goes down again, it's up, this bell. Where is the top of the bell? The top of the bell is the mode. But from a sample of data, unless my data has been grouped, I'm not going to get that. So ignore this thing, not important. Other things here, skewness. Is our data bunched at the bottom and with a long tail to the right? Or does it have a long tail and it's bunched or on the right? So how is it? You can see that easily in a picture, and you can talk about, is it skewed to the left? Is it skewed to the right? Does it have a long tail to the left or the right? Do I want to summarize that with a number? Oh, don't bother. don't use this. Nobody does. Well, I know very few people that have. Kurtosis has to do with, even if you have a bell, is it a bell that has a sort of big fat side here, comes up as a big spike in the middle and then a big fat piece over on the other side? Or is it very skinny, tapers up, big rounded sort of bell here? Is the middle spread out with skinny tails, or is the middle compressed and tall with fat tails? That's kurtosis. You don't care about that. It's not important to us, not within most applications. So a bunch of these things don't worry about. Standard error is something that's special, and I want to end today talking about it. So I filled in all of those things, and I just explained those various terms that are there. So standard error. I have numbers for 752 students. The mean value is $53,000. And if I said, I made some pronouncement that the mean salary expectations of St. Mary's students in 2010 was $53,000, someone might say, is that exact as the mean? Or is that just your best guess? Or is it just that there are lots of values around 53,000? Oh, okay. It was based upon 752 responses to a survey. It's a lot of data. So I think this is a fairly accurate figure. What do you mean by accurate figure? Is the right number 53 if I got data on every possible student? Would I get 53 or would I get 58, 71? Could it be the real number? Could it be 39,000? Can you tell me what you mean by accurate? Don't just give me a word, but give me a number. How far off do you think your estimate is? Do you think your estimate is off? Could be off by $1,000 or $2,000? Could it be off by $5,000, $10,000? How far off? Well, you could imagine if you'd gone out, repeated the survey, and you got a different group of 752 students to respond. Back at the time of the survey, we had a student population of 7 to 8,000 students. So this is maybe 10% of our students. So if I went out and I grabbed a different group of 10% of our students, what average would I get? Would I get something around 53? If I went out and took another survey, I calculated a new average. What would I get? Around 53? If I did this hundreds of times and calculated all the averages and looked at them, I'd find them bunched in the middle. And then sometimes I got really high averages and sometimes really low averages. Sounds like a bell-shaped curve. It is. And it turns out it would look like a bell-shaped curve. How variable are these averages? Variable of the average? Okay. They're different from each other, so they're variable. They're diverse. Standard error is that variability, and I could sort of use empirical rule. I could say that I think my estimate could be off by one standard error. About 68% of the time, my estimate is off by one standard error. Or by one standard error or less. 95% of the time, my estimate is off by less than two standard errors. And rarely is my estimate off by more than three standard errors. So I might say, okay, maybe it isn't $53,000. Maybe it's as low as 50,000. Maybe it's as high as 56,000. But it's not 60. It's not 45. It's somewhere between 50 and 56. Does that help you understanding what accuracy means? Standard error helps us measure accuracy of estimates. This is a big topic within a statistics course. They do it in a more formal fashion. Unfortunately, students get so confused and obsessed with formulas and technical things of how to calculate it, they forget what it is. It's just your best guess of how accurate an estimate is. That's how we use standard error. We use it the same way we use standard deviation, and its origins are similar. Its interpretation is very, very similar. So what we did today, we looked at some of the most common summary measures, and really the summary measures people look for are what is in the middle, what's high, and what's low. The middle, they typically look at the mean or the median. The mean is the most commonly used one. The median is nice because if you can't do calculations, don't have a calculator computer. Median is a convenient measure. It also has certain intuitive appeal when your data is not balanced. High and low, quite subjective, different ways we could measure it. That the best way for me is to use standard deviation and use empirical rule. And standard deviation is this very abstract concept of measuring diversity of values in a number. And that's hard to necessarily wrap your head around as a specific number. But within empirical rule, I can use it to quickly give me ideas of what is very low, low, middle, high, very high. And standard error is used when I'm not talking about the data, but the precision of estimates from the data. So if I'm measuring a mean value, how accurate is it going to be? My estimate, what's my high estimate, low estimate of what the mean is? I can use standard error to come up with those. So that's it for today. And next class, we're going to get into pivot tables, which are a really nice tool for doing a lot of the stuff that, particularly when looking at comparisons and relationships. But before I run away, I've got to get back here point out the problem people are having in Excel with VLOOKUP. So in VLOOKUP, we had a case here where we had a lookup table for home to translate 7 into a location. And so we had a lookup table here, and so the way we did this was we took this, we inserted a column, or here, let me go and do that. Well, I can do it again. So I inserted it, and I created a VLOOKUP where it took this number and gave it a new value. On your sheet, I'm currently in the Home tab. So this is the one where it gives me the formatting of things with coloring and font size and those types of things. There is one block here in the middle called number. Now you could change things to dollars or percents or that type of thing. There's a variety of choices. Most of the time, Excel starts out saying it's general, and that's where we want to be. But what happens if let me take this guy out, okay? Let me take a bunch of these guys away, okay? And suppose I want to type in the formula I'm supposed to be doing. But instead of it being general, it's text. I never pay attention to this. Most people never pay attention to it. They just assume it's general up there. But this is what happened to me, and now it's happened to a whole bunch of students. I'm typing this in. It's behaving just the way I want it to. It's prompting, oh, there's a function you're putting in here. And I take the value that's in F2. I've got my lookup table. Grab it. I hit F4 to put dollar signs around it. New values in column 2. And I want an exact match. I hit false. Oops. Close bracket. Enter. What's going on here? It didn't fill in anything here, and it still got my formula up here. Yeah, my formula, everything's fine. You want to wrap text, it's all there. It thought it was text. Thought I was giving it words. It ignored the fact there was an equal sign. I know initially it thought it was an equal sign because it helped me build the formula, and it knew it was the VLOOKUP formula. But it's not treating it that way. But if I go and change it to general now, whoops, it's still thinking it's text. Yeah, sometimes it does, sometimes it doesn't. Now, hopefully, anyway, if I type in here equals VLOOKUP, okay, Hopefully this works on me. F2, comma, where's my lookup table? Hit my F4, comma, 2, comma, and I want false here. Got everything in here, I think. Oh. No, I've got, somehow I put an extra bracket in here. Excuse me. There. Now I think I'm okay. I still don't like it. Excuse me. Hey, look up. There we go. And I want F2, comma. Now it's moving over. Table. As I type things, I don't know if you notice, it, it's got something in bold, and it's just showing me what's next. There we go. It didn't tell me this thing at the end. And now, see, it worked properly. It's messing up the rest of my table because I messed it up earlier. But at least now I think this is showing me Nova Scotia. There we go. So it's working for that one, and it'll work for the rest of them afterwards. But it's, if the cell is showing up as text, your formula is not going to work. That's it for today. Please start doing assignment 1. That look at the stuff that's posted. I will change the settings on those videos so you can see them. And if you got questions, email me. The Math Help Center is also available to you. I'll be doing a workshop for them tomorrow on this assignment, so they're ready. So they may not be quite ready for your questions today. And we will look back at any questions you've got at the start of class on Wednesday. Okay. So say if you get stuck, stop and ask questions. Don't just keep trying to, spend a little bit of time trying to figure it out yourself. But don't get, if you're starting to get frustrated, then it's time to stop and to send me a message. Okay? Take care. Bye-bye.